Welcome everyone. Today, we'll discuss Welder Qualification according to API 577. This standard provides guidelines for welding inspection and qualification to ensure weld quality and compliance. Our goal is to understand why welder qualification is critical and how it's implemented in practice. Welder qualification is a key component in maintaining safety and quality in industrial welding. In this session, we'll cover the importance of welder qualification and how API 577 sets the framework for this process. API 577 provides guidelines for welding inspection and qualification processes to ensure weld integrity and compliance with industry standards. Welder qualification is a critical process that verifies a welder's ability to produce sound welds under specified conditions. This qualification ensures that welders possess the necessary skills and knowledge to meet safety and quality requirements in construction and maintenance projects. The standard outlines procedures for welder performance qualification or WPQ, including essential variables, testing methods, and acceptance criteria. Understanding these guidelines is vital for inspectors, engineers, and welders to maintain consistency and reliability in welding operations. Welder qualification is essential for ensuring structural integrity and safety in pressure vessels, pipelines, and other critical components. Improper welding can lead to catastrophic failures, financial losses, and safety hazards. By qualifying welders according to API 577, organizations can minimize risks, comply with regulatory requirements, and maintain high-quality standards. It also helps in reducing rework, improving productivity, and ensuring that welders are competent in handling specific materials, positions, and welding processes. This process builds confidence among stakeholders and supports the overall reliability of industrial operations. Next, we'll dive into WPQ, Welder Performance Qualification. This process certifies a welder's ability to produce acceptable welds under defined conditions. Welder Performance Qualification or WPQ is a documented process that certifies a welder's ability to produce acceptable welds under specific conditions. The objective is to confirm that the welder can consistently meet the mechanical and visual requirements of a given welding procedure. WPQ involves welding a test coupon under controlled conditions, followed by inspection and testing to verify compliance with acceptance criteria. This qualification is not transferable across different welding processes or essential variables, meaning any significant change requires requalification. WPQ ensures that welders are competent for the intended scope of work and helps maintain uniform quality across projects. Essential variables are factors that, when changed, can affect the welder's ability to produce acceptable welds. API 577 specifies these variables, which include welding process, base material type, filler metal classification, welding position, joint design, and thickness range. For example, a welder qualified for carbon steel in a flat position may not be qualified for stainless steel or overhead positions without requalification. Understanding and controlling these variables is crucial for maintaining compliance and ensuring weld quality. Inspectors must verify that the WPQ documentation accurately reflects these variables to avoid misapplication in production welding. Now, let's look at the WPQ process and testing methods. This includes steps from WPS selection to inspection and documentation. The WPQ process begins with selecting the appropriate welding procedure specification or WPS and preparing a test coupon that meets the required dimensions and joint design. The welder performs welding under supervision, ensuring adherence to the WPS. After welding, the coupon undergoes visual inspection for surface defects, followed by non-destructive testing or NDT such as radiography or ultrasonic testing to detect internal flaws. Destructive tests like bend tests or tensile tests may also be conducted to evaluate mechanical properties. The results are documented in a WPQ record, which includes welder identification, test details, and acceptance criteria compliance. Testing methods for WPQ include visual inspection, NDT, and destructive tests. Visual inspection checks for surface defects such as cracks, porosity, and undercut. NDT methods like radiographic testing or RT and ultrasonic testing or UT detect internal discontinuities without damaging the weld. Destructive tests, including bend and tensile tests, assess the weld's mechanical strength and ductility. Acceptance criteria are defined by API 577 and related codes, specifying allowable defect sizes and mechanical property thresholds. Compliance with these criteria confirms the welder's capability to produce sound welds under specified conditions. Reviewing WPQ documentation is critical. Inspectors must verify essential variables, confirm test results, and ensure documentation completeness for compliance. Reviewing a WPQ involves verifying that all essential variables and test results meet the specified requirements. Inspectors should check welder identification, WPS reference, welding process, base material, filler metal, position, and thickness range. The review must confirm that the test coupon passed visual, NDT, and destructive tests as applicable. Documentation should be complete, accurate, and signed by authorized personnel. Any discrepancies or missing information can invalidate the qualification. A thorough review ensures compliance with API 577 and prevents unqualified welders from performing critical work. Common errors in WPQ review include overlooking essential variables, accepting incomplete documentation, and failing to verify test results. These mistakes can lead to non-compliance and compromised weld quality. Best practices include using a standardized checklist, cross-referencing WPS and WPQ details, and ensuring traceability of records. Inspectors should maintain vigilance and apply a systematic approach to avoid errors. Regular training and audits can further enhance the effectiveness of WPQ reviews and uphold industry standards. Proper documentation ensures traceability and compliance. Records should include welder details, WPS references, test results, and signatures. Proper documentation of WPQ is essential for traceability and compliance. Records should include welder details, WPS reference, test results, and signatures of authorized personnel. These documents serve as evidence of qualification and are often required during audits or inspections. Maintaining organized and accessible records helps ensure accountability and facilitates quick verification when needed. Digital record-keeping systems can improve efficiency and reduce the risk of lost or damaged documents. Compliance with API 577 requires adherence to its guidelines for welder qualification, testing, and documentation. Organizations should implement robust quality control systems, conduct regular audits, and provide training to personnel involved in welding inspection. Compliance not only ensures safety and reliability but also enhances reputation and reduces liability. By following API 577, companies can demonstrate commitment to industry standards and maintain operational excellence. WPQ verifies welder competency and ensures quality welds. Reviewing documentation prevents errors and maintains compliance. Adhering to API 577 supports project integrity. Welder Performance Qualification or WPQ is a critical process that ensures welders are competent to produce quality welds under specified conditions. Reviewing WPQ documentation is equally important to verify compliance and prevent errors. By understanding essential variables, testing methods, and acceptance criteria, inspectors and engineers can uphold industry standards and maintain safety. Proper documentation and adherence to API 577 guidelines are key to successful welder qualification and overall project integrity. Organizations should prioritize welder qualification and WPQ review as part of their quality assurance programs. Implementing best practices, such as standardized checklists, thorough documentation, and regular training, can significantly reduce risks and improve outcomes. By fostering a culture of compliance and continuous improvement, companies can ensure safe, reliable, and efficient welding operations that meet or exceed industry standards.